Welcome back, students, to Experiment 2 for Chem 102. My name is Professor El Hawari, and today we will be covering the second experiment, which is called Physical Properties, Density of Solids, and Their Solubility in Water. So, the first task that I want you to do is to make a copy of the lab report. So, here is the lab report. I will be attaching it to Brightspace. Your goal is to make a copy of this. So you can go to File and then make a copy. So you can have your copy for this lab so you can edit it as we're going. Or another thing you could do is that you can print out this lab report and complete all of the parts by writing it. And then you can take pictures of your completed lab and upload it to our assignment. So you can either complete it digitally and then upload it to the assignment, or you can complete it by hand and upload it to our assignment. So let us start. Here is the PowerPoint, and let us complete experiment 2. So the first thing I want you to do is that at the very top, put your name and the date that you are completing the lab. So the date that you are hearing this video. So the directions, the first thing, as we did in the previous experiment, is to write one sentence that clearly describes the objective and the goal for this lab. So the objective that I want you to write, so you are going to write it in right here, is that the objective of this experiment is to determine the density of solid materials and to investigate their solubility in water. We will be defining the word solubility, and we are going to give a definition of density during the lab. So, again, the objective of this experiment is to determine the density of solid materials and to investigate their solubility in water. So, pause the video and write that under objective. All right, now the goal for this lab, you can write down the goal for this experiment is to measure the density of solids and assess their solubility in water to better understand their physical properties. Again, the goal of this experiment is to measure the density of solids and assess their solubility in water to better understand their physical properties. So you can rewind the video and write down the goal for our experiment, experiment number 2. So now we are going to talk about the theory behind today's lab. So the most important thing we're going to talk about today is water. As you know, water is important for all known forms of life. We are dependent on it. 60% of the human body is made up of water, and water actually, believe it or not, covers 71% of the Earth's surface, mostly in seas and oceans. And again, one thing we're going to also talk about this year is that chemical reactions in our body occur mostly in water solutions. So the reactions occur in water, and water is very important, not just for life, but also in chemistry. And a little bit more facts about water. Water is about 70% of fresh water used by humans goes to agriculture, and water has an incredible ability to mix homogeneously with many different substances. What do we mean by that? If you take salt that you eat on a daily basis and you drop it in water, if you mix it, it's going to mix evenly. And this even mixing, we call it a homogeneous mix. If you take vinegar and you add it to water, it will mix in water. So that's a homogeneous mixture. And some substances do not mix well with water, like oil, and these are called heterogeneous mixtures. Now, let's talk about density. Density is very important. It's a very important concept that we talk about not just in chemistry, but in science in general. So density is a ratio of mass to volume for any sample of matter. The formula that we use to calculate density is density equals mass divided by volume. This ratio gives rise to density. So, how do we visualize density? Density represents how particles are packed together. If the substance has uh, atoms that are very packed together, we say they are very dense. If the substance are not packed together, we say they are less dense. So there are, if you look here, cork, water, brass, and liquid mercury. The density for liquid mercury is 13.590 grams per milliliters. And notice, where is liquid mercury? It's all the way at the bottom of our beaker. Now let's look, for example, at cork. The density of the substance cork, which is a solid, is between zero point 0.22 and zero point 0.26. Notice the density of cork is way less than the density of mercury. So, what observation can you see here? Which substances float? Would you say the least dense or most dense? So, as you can see, the substance that floats are always the least dense, and the substance that's all the way at the bottom is the most dense. And the substances in the middle here, water and brass nut, have varying densities. So the densest would be liquid mercury, followed by brass nut, followed by water, and cork, the least dense, will float at the top. So typically, again, as we said, in order to calculate density, you need to measure two things. You need to measure mass, and you could do this using a balance, and you have to measure volume, which we need a special glassware in order to do so. You can use a graduated cylinder, which we're going to be talking about in a little bit. Uh, and if the substance is irregular, we can calculate the volume by displacement. So, one thing is that density is a physical property of matter. It's not a chemical property, it's a property that allows us to understand the behavior of the substance that we're studying. So, the density of a particular substance is the same no matter how much or how little you have of it. As an example, if you have a piece of cake, if you eat a big portion of the cake versus a small portion, it will taste the same. Or if you have soup, if you drink a cup of soup versus a spoonful of soup, it should still taste the same because the density is the same. So, density is a characteristic property. So, it could be used along with other properties to identify matter. As you can see, if I tell you the density is 0.876, when I tell you this, you can say, oh, this density corresponds to benzene, for example. So it's a way for us to identify different substances. And density usually decreases when temperature increases. That's for uh, certain phases of matter. And one thing, density changes when you dilute it, which means when you add water to something, you change the density. Now, generally, solids are the densest state of matter, and gases are the least dense, and liquids have densities in between. Now, this word homogeneous we talked about earlier, so we say different materials that cannot mix homogeneously will float. So, as you can see here, cork is not going to mix with liquid mercury, so that's why it floats all the way at the top. And as we said, this is very important. That's why we have it boldened. Materials that are less dense than water will float on water, and materials that are more dense than water will sink in water because they have a higher density. Now, let's talk about the word solubility. Solubility, the definition of it is the ability of material, the solute, to mix homogeneously with another material, the solvent. As an example, here we have water and water would be considered the solvent, which is the thing that we are going to place the solute in. The solid that you see at the bottom is called the solute. That's the substance that we're trying to dissolve. So if I were to ask you, is this solute, this mystery solid, is it dissolving in water? And the answer is no, it's not dissolving because it's settling to the bottom of the test tube. Since it's not dissolving, we say this salt has low solubility in water, or we can say it's insoluble. Now, another point is water is a very common solvent, and other solvents that we could dissolve things into are alcohols, acetones, and some acids. And now we're going to talk about the definitions for solubility. So the two important words that we want you to know is that the word soluble. So if a material mixes homogeneously, which means it mixes evenly in a solvent, we say that the material dissolves in the solvent, and the definition is soluble. So can you think of any substances that if you put in water will be able to dissolve? And the answer could be salt, table salt. If you take salt and you dissolve it in water and you mix it, it will dissolve. So we say salt is soluble. Now, on the other hand, if a material cannot mix homogeneously or evenly in a solvent, we say that the material does not dissolve in the solvent, and we say the material is insoluble. And the example here in the picture is an example of an insoluble solute that we're trying to dissolve in water. So, another key distinction is that melting and dissolving are not the same thing. They sound similar, but they are very different. Melting means that one material changes from the solid to the liquid state by absorbing enough energy at a certain temperature. That's melting. For example, when you go from ice to liquid water, that's called melting. And that's only one material. You go from ice, which is water, to liquid, which is water. So you go from water to water, that's melting. Now, dissolving, on the other hand, is a little bit different. Dissolving means that you take two materials or two substances that you're trying to dissolve into each other. So dissolving means that a material evenly mixes with another material. So melting requires one substance, but dissolving requires two substances. Now, if you want to dissolve a solid in water, you typically need to swirl it or stir the mixture in order for the dissolving to happen. Again, if the solid dissolves in water, which means it's soluble, you're not going to see any crystals at the bottom or powder after swirling. Everything is going to, it's like a magic trick, it will disappear. Now, some solutes are only slightly soluble in a particular solvent. Only a small amount dissolves, and the rest settles to the bottom. You can see this. Let's say when you're drinking tea, if you add sugar initially, it will evenly mix. But if you kept adding more and more and more sugar, eventually it will settle to the bottom because every liquid has a maximum amount of solute that you can dissolve into it, and it's called the saturation point. It's like a limit. You can only dissolve a certain amount of solute before the rest settle out to the bottom as precipitate, which we're going to talk about later. All right, so here's the experiment on the data sheet that you see on your lab data sheet. The equipment that we'll be using in this is the beaker, tweezers, scopula, disposable pipette, and stirring rod. So I want you to write the equipments here, and I want you to list the functions. So we talked about this in experiment one, so we're gonna go over this briefly again, the equipment and the function. So let's start. So for the first box, write tweezers, the equipments we'll be using. And for tweezers, you're going to write the function is Tweezers in a chemistry lab are used to safely handle small or delicate objects without direct contact. Again, pause the video, write down the equipment and function, and then go on to the next equipment. Scopula. A scopula is used in the chemistry lab to transfer or scoop small amounts of solid chemicals. Beaker. A beaker is a common lab container used to hold, mix, and heat liquids during experiments. The beaker is right here. Disposable pipette. A disposable pipette is used to transfer small volumes of liquids accurately and safely, then discarded to prevent contamination. And last but not least, the stirring rod. A stirring rod is used to mix chemicals and liquids smoothly and safely in the lab. All right, so again, we reviewed the materials. Now let's review the procedures now. For this experiment, we will be testing the solubility. So we're going to get 8 beakers, fill each of them halfway with water. For example, if you have 100 ml of beaker, we're going to only add 50 ml of water. Place each sample into a separate water-filled beaker using tweezers or scopula. Note whether each solid sample sinks or floats. So now we are testing for the density. So sinks or float, we're testing for density when mixed with water. We're going to write down the observations for table 1. So go to table 1 for the lab data sheet and we are going to fill it out. Based on our observation, we're going to write whether the solid is less dense or more dense than water. And now we're going to stir the contents and note whether each solid dissolves in water. That's for table 2. So table 1 will be for density and table 2 will be for solubility. So again, table 1, sinks or flow, you're going to write for table 1 under observation right here. If it sinks, you're going to write sink. If it floats, you're going to write float next to each sample. And conclusion, if it you're going to write either more dense or less dense. So if it sinks, more dense. If it floats, less dense. For table 2, the observation is either dissolves in water or does not dissolve in water. Now, if it dissolves, that means it's soluble with an S. If it does not dissolve, that means it's insoluble with an I. So now let's start the experiment with some videos. So the first video is for wood, styrofoam, glass beads, and metal. So let's start some water. We're dropping some wood in some water. And as you can see, is it sinking or is it floating? It looks like it's floating. So for observation, you're gonna write floats. And if it floats, is it more dense or less dense? That means it's, yes, less dense. Very good. Next up, the styrofoam. Styrofoam, as you can see, is it sinking or is it floating? It is floating in water, so that means it's less dense. Now let's take the glass bead. So the glass beads, drop them in water as we're doing here. Look, okay. So the glass beads actually sink to the bottom, as you can see in the video. So you're gonna write sinks, and since they sink, what's the conclusion? The conclusion is that glass beads are more dense than water. Look, as we keep adding glass beads, they keep going to the bottom. All right. And we have the last but not least, we're gonna have the metal. Oh, here is the metal paper clip, piece of metal. We're gonna drop it in water, and now we're gonna notice where is it gonna go? Is it gonna go to the bottom or is it gonna float? Drop it, yes, so it goes to the bottom. So the metal sinks, and therefore it is more dense. Again, here are the observations one more time. And you again, if you want to pause the video and rewind, do that. All right, so this is before stirring. Now let's do after stirring now. So after stirring, this is now go to table number 2. So we're gonna pause, leave table 1. Let's go to table 2, and let's try to stir these. stirring them to see if they dissolve in water or not. All right. So we're trying to stir wood. Now, does wood dissolve in water? And the answer is no. What about styrofoam? Does it dissolve in water? And the answer is no. So you're going to write does not dissolve for observation. Let's look at glass. Does glass dissolve in water? No, it does not. So you're going to write does not dissolve. How about the paper clip, the metal? No, it does not dissolve. So for the observation, you're going to write does not dissolve. And for all four, the conclusion would be that they are insoluble. Insoluble means they do not dissolve in water. All right. So fill your table number 2. Now let's go back before and after stirring. Now this is for table 1 and 2. We are going to talk about magnesium hydroxide, table salt, table sugar, and sodium bicarbonate. So now let's test it. We're going to take magnesium hydroxide and put it in water. Now, does it sink or does it float? Let's see. Now, if you look closely, you'll notice it might not look it might not be visible because it's actually mixing. So magnesium hydroxide actually sinks. So you're gonna write sinks and it's more dense. And look, we're trying to mix it. Does it mix? Yes. So you're gonna write mixes. So you're gonna write dissolves and soluble. So dissolves and soluble. Now let's look at sodium chloride, which is table salt. Here it is. That's salt. We're gonna take salt and we are going to add it to water. Notice we are adding it. All right. Notice, does it float or does it sink? It does sink. Look, the salt is all the way at the bottom. So you're gonna write sinks and more dense for table 1. Sinks and more dense. Now what we're gonna do is that we are going to stir it. So let's stir it now. Yes, we're just focusing the camera so you can see it. Here it is. That's the beaker. Yes. You can see the salt is all the way at the bottom here. Salt is all the way at the bottom. Now we're going to take the stirring rod. We're going to stir it. Yeah, notice the salt is dissolving. Yes, as we are doing it, the salt is dissolving more and more. So you're going to write table salt dissolves and soluble. See, all as we're mixing, the salt is disappearing. Yes. See? So we say this is a homogeneous mixture. Everything is evenly mixed. Everything. So sodium chloride, which is the formula for salt, dissolves in water. Now let's do sucrose. Sucrose, which is table sugar. So right, table sugar. We're gonna add sugar to water. Now, as you can see, when we add sugar to water, again, it goes all the way to the bottom. So for table 1, the observation would be sinks. And because it sinks, that means sugar, which in our case sucrose, is more dense. More dense. See, it's going to the bottom. You can see it's yeah. And we're stirring the sugar now, the sugar water mixture. Yes. So the goal is to find here: does sugar dissolve in water or does it not dissolve in water? Now we should know this from our experience. When you put sugar in water, it does dissolve in water. So as you can see, just give it a little bit of time. Again, dissolving is temperature dependent. The temperature of the lab, if it's a little cold, the sugar will not dissolve completely. But look, if you keep looking, the sugar is dissolving. So we're gonna say sucrose dissolves in water and it's soluble. So that most of the sugar that we added, but you can see a little bit of crystals at the bottom. And why is that? Because every amount of water can hold only a maximum amount of solute, and that's just temperature dependent. But notice most of the sugar that we added dissolved, but we still have a few crystals, and that's understandable because uh, the water, it took all of the maximum amount that it needed. Yes, so that's it. Now we're going to, yeah, we're trying to get the last piece, but there is a maximum amount, maximum limit. All right, now we're going to go to the milk. Oh, but look, see, it's mixing. Now the last portion is the milk of magnesia. And let's go to the milk of magnesia now, right here. No, actually, sodium bicarb, sodium bicarbonate. Yes. So now, not milk of magnesia, we're going to do sodium bicarbonate. See, we're going to add sodium bicarbonate to the beaker. Notice the sodium bicarbonate, just like salt, just like sugar, they go all the way to the bottom. So for table one, you're going to write sinks, and it's more dense, sinks and more dense. And now we are going to try to dissolve it with the stirring rod. And notice, what do you see? Yes, it does dissolve. So sodium bicarbonate does dissolve. So for table two, the observation will be dissolves, which means it's soluble. It is. So sodium bicarbonate is soluble. So just write it for magnesium hydroxide, table salt, table sugar, and sodium bicarbonate. All right, so this wraps up experiment number two. So now you are expected, watch the video, complete the quiz based on the experimental video. So the quiz will be on Brightspace, and make sure to submit the lab report. So as I said earlier, you can make a copy of the template and edit it online, or you can download the lab, fill it, and then take pictures of it and upload it to our Brightspace. Thank you, and see you soon.